Okay, so first we'll solve some of the left sums here, then we'll move on to the next sum. We'll see it's 4 to 5 sums. So in 72 sum, you can see the distribution here. Okay, so describe the overall shape of the distribution of calories. So how's the shape of the distribution of calories? Okay, we'll take it on our boards. Okay, so describe the overall shape of the distribution of calories. So when we will plot,
It's roughly symmetrical. It's a
correct,
bell curve.
roughly symmetrical. All right. Okay, and what is the approximate center of the distribution? So what is the approximate center of the distribution? Means he's asking the median,
It's in the center.
which is in the,
Median.
yes, he's asking what is the approximate center of this distribution. So what is the center of the distribution? Means the median.
In the center.
So, yes. So what
Yeah,
we need to do?
median. Yeah.
Yeah, what we need to do here, first we have to see 160 is the highest and the 50 is the lowest. Yes or no?
Yes.
So what will be the exact center? I think 160 and 50 to 160. So I'll leave 1, 2, 3, 4. 1, 2, 3, 4, 5, 5, 6, 6. So I think so. This 110 is the exact center. So this will be in the median. Okay.
Mm-hmm.
Okay. Next, explain why you cannot find the exact value for the maximum number of calories per serving for these cereal brands. Between what two values does it lie? Okay. See, this is a histogram. Histogram. So your median lies between 110 and 120. Okay. So histogram has intervals. We have seen for plotting of histograms, we need to take out the intervals. So he's explaining, he's telling us, explain why you cannot find the exact value of the maximum number of calories. So maximum number of calories, I think it's around 28, but we cannot give it as exact number because this bin is for an interval 110 to 120. Yes or no?
Mm-hmm.
We cannot give it the exact value. Likewise, it can be 112 or 113. Why we cannot give it the exact value? Because histogram, because histogram is plotted for interval data on the x-axis. Interval data on the x-axis. That's the reason. Understood? So the last question is
Mm-hmm.
about what percent of cereal brands have 130 or more calories per serving? 130 or more. So 130 or more. So I need to draw this here 130. So first bin is around I think two. So two. Second bin is around second bin. I take it three, and the third is also three. So three plus three 7 upon what is the total? 130 to 140 is 10, 10, 20, 30. 70 upon, it is asking about what percent of the cereal brands have 130 or more calories. So what's the total? 50 to 160. I think 110. 7 upon 110. This is the percentage of cereal brands having protein more than 130. Is it clear? 7 is the count, our count, and
Mm-hmm.
total is 110. So it will be 7 upon 110. Moving on to the next question. Question we will look upon. So we shall start the next chapter. We'll solve this some problem of mean and median. Yeah. There is no median and the total, right? This was the last thing that we have studied. Okay, so this is the 92 question. Okay. Birth rates in Africa, one of the important factors in determining population growth rates in the birth rate per 1,000 individuals in a population. The dot plot shows the birth rates per 1,000 individuals, rounded to the nearest whole number for all the 54 African nations. Find the median. How you will find the median? Say? What we need to do?
Find the middle between all of these.
Correct. Find the middle. So what will be the median? Come on, calculate and tell me. Come on, do it on a paper.
No, no, I will.
Okay. You're doing it, correct?
Yeah, I'm just, yeah, calculating.
See, you'll have to count the data points. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30,
38.
31, 32. Oh,
38
there
is
are
the median.
54, I think. So what? How many data points are there? You
54.
have
I
counted?
think there's, yeah, there's around 52.
Oh, wait, I will count. Sorry, I missed the count. 3, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. So there are 54 data points. So what we need to do, it is an even number of data points. Okay, so
Yeah.
54 divided by 2 will be 27. Yes or no? So we
Yeah,
need to
so,
take the 27
yeah,
data
so
point
it's gonna be,
and the 28 data point, correct? And take the mean of it. Yes or no? Divided by 2. We'll add the 27 and 28 data
yeah, I
point
think
and
it's just
divide it by 2.
38.
So you think it's
I think
38.
it's just 38.
Okay, we'll see now the 27 and 28. 1, 2,
Okay.
3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, 27. So 27 is 37 and 28 is on 37, 38, 38,
Oh,
38. So it will be 37 plus 38 upon 2. So it will
oh,
be,
oopsies. Vape is 37.5.
yes, 37. Good, good. You were near about correct. Okay. Without doing any calculation,
Yeah.
explain how mean and median compare. Explain how the mean and median compare. Okay. So without doing any calculation, we have to explain. So we'll need to draw the distribution of the data. Then only we can compare the things. So how's the data? How the data says?
It's a
Data.
little
I'm
left
telling about the
skewed.
distribution. Left
Skewed to the left.
Very good. Skew to the left. Yes, that's the spirit, man. So where will be the median? We have seen. Where is the median here? I think it's here. Okay. So it's left skewed. So this is the middle. So left skewed means there is an outlier at the left. So will the mean shift towards the left or towards the right?
To the left.
To the left. So means left indicates less value. So mean will be less than median. Yes or no?
Mm-hmm.
Yes. As the distribution is skewed to left. Yes, that's good. Is the value you find in part A, this part A, a statistic or a parameter? Okay, that's a good question. That's a good question. I like that question.
Population. It's a population once a parameter.
Yeah,
It's
yeah,
not a
yeah. Good.
sample.
Yes, very good. It's about the population because he has given here one of the important factors determining population growth rates is the birth rate per thousand individuals in a population. The dot plot shows the birth rate per thousand individuals rounded to nearest whole number for all 54. Yes, correct. It's about the population. Very good. Very good. Okay. Now we'll move on to the next question. We'll see a next question. Just like this. See, this 96 and 95. Do it as homework. Mark it. You'll do it as homework. Mark that homework 95 and 96. This can come in your exam.
Okay.
Okay. So he's telling us to 90. You know how to find the range? Maximum minus minimum. I'm looking of a
Mhm.
question where we need to find. Uh, okay. Okay. So what here are a box plot and some numerical summaries of the electoral vote. This is given there. So explain why the median and IQR would be a better choice for summarizing the center and variability of the distribution of electoral votes than the mean and the standard deviation. We have seen this type of questions in our solved examples when we were solving. Come on, tell me the answer for the first. You
Huh?
must know the answer. We have discussed this point in our class.
Explain why. Um,
As median and
because
IQR median, I'll tell you the answer. Median and IQR are resistant, and mean and standard
they don't
deviation.
change despite the
Correct,
outliers.
correct. Are not resistant. Therefore, we prefer median and IQR for calculating the. We prefer, we prefer this. Okay, understood? Okay. Then
Yeah.
identify an aspect of the distribution that stem plot in exercise 9 reveals. This is the question. How many outliers are there in the data? Looking at the box plot.
Um. Mm, there's supposed to be. There's like three.
Three, correct. This one. This. The points outside the box plot are always the outliers. Remember this. Outside this upper fence and lower fence, all the points that are outside this are the outliers. Okay, so that's enough from the first chapter. Now I think we shall move on to the second chapter. You must practice all these sums, and any difficulty I've repeated several times that you must get back to me. Is there a solution textbook also for all these exercises, right?
Yeah,
So where it is given
it's
at the
at the
end,
end.
Pawan? Okay, 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 okay. So you can
Yep,
refer
it's
that
at the
also.
end.
Correct. Okay. Okay. Now we come to chapter two. So see what all we are going to study. Chapter 2, it's in the chapter. This is unit 1. We have not see. We have taken around this our 12 lecture, and we are on unit 1. So unit 1 is much bigger. See, one fourth of our textbook. If we'll finish unit 1, one fourth of our textbook will finish because unit 1 is more descriptive. There is more definitions there. Okay, and if possible, if we finish that book earlier, so we'll solve more examples from all the units. Okay, but I'm telling you,
Mhm.
you must go on solving the examples of Unit 1 now. Start it. Don't waste your time. Okay? Anything you didn't get it, mark it there. And when we have a class, we'll discuss it in the class. Okay. Now, this is the activity that he is going. So, okay, describing location in a distribution. So, we are going to start with chapter 2. Chapter 2. Chapter 2. And the first topic that we are studying is describing location in a distribution, describing location in a distribution. That's correct. That's simple. Nothing big in it. It's very simple. See, he's telling us by learning targets, by the end of the section, you should be able to find and interpret the percentile. Percentile is likewise something as quartile that we have seen, but percentile does not deal in what you say numbers, it deals with percentages. Uh, okay. Estimate the percentile and individual values using a cumulative frequency graph. Find and interpret the standardized score. This is one thing, standardized score, which is known as Z score of an individual value in a distribution of Z data. Z score is very important. I'll explain you one thing of Z score here as it has come for Z score. Z score.
Oh, Z score. Okay. Yeah.
Z score, yes. Z score. Z score.
Z score, Z score. Okay.
That's yes. So it is something x minus mu upon sigma. Yes or no? So what it is?
So
For
that
suppose
is.
I am measuring two columns. I am comparing two columns in a data. For suppose I am weighing what you say the bicycle's weight. So it's around 110 kg. Weight of bicycle, and I'm weighing weight of its engine. Its engine. So it's coming to be around it's 110
Mhm.
kg and it is coming around 2000 grams. Okay. So see the these things are in different what you say units. Yes or no?
Yes.
So in this case,
Correct.
we need to apply the Z score and bring it to standard form. So does it do? Bring this all these values into standard form between 0 to 1. When all the entries in the rows of the weight and in the weight of the engine and weight of the bicycle will come in between 0 and 1, then we say that it has come into Z score. That's the thing. So we'll see when it comes. Describing the effect of
Mhm.
adding, subtracting, multiplying, or dividing by a constant on the shape, center, and variability of the distribution. If we are multiplying some constant to the data, to the table, we can see the variability in our graph. So these are the four topics that we are going to study. So first of all, describing a location in the this see in this graph. Uh, Describing a location means we are.
Mhm.
I'll check on this graph. Today you will be available in the evening, right?
Mhm.
Today there's Sunday there.
What? Hello?
Today there's Sunday. The day today.
Hello?
No voice is not coming, right?
Wait, I can't hear you. What? You're logging out. What?
Today there's Sunday in California.
Yeah, today's Sunday for me. Yeah,
Correct, correct. For you. Okay, here it's ending. In 2 hours, it will be Monday nights. Okay, so it will be the Monday will start. Okay.
I
I
see.
wanted to ask you one thing. From tomorrow onwards, you'll attend only one class, right?
Yeah, only
From
attending
what?
one class from tomorrow.
From tomorrow, you'll join us. Can you repeat?
What?
Can you hear? Can you hear me there clearly, or my voice is breaking?
Yeah, I can hear you now. Yeah. No,
Okay.
it's good now. It's good now.
Okay. So describing a location here. So see, all the data points are in blue, and one data point which we have to describe in the whole data is in red. Yes or no? So this is how we describe. This is how
Yeah.
we describe the location of a specific point. A location of a specific point in the data. Specific point in the data. This was the thing. So, dot plot of scores of 50. So this is how we define the location. So we now come on to the major thing that this is describing clear.
Yeah.
Okay, if I tell you
Very
which is the
clear.
25th point in the data, so what you'll do, you'll just take the thing and you'll mark it as red. Yes or no? So what you have done,
Yeah.
described the data. Okay, now we'll move on to the next thing. That's the next topic. We have seen how to describe the location in a data. So the second is percentile. Very important. Percentile. We you have seen percentage. It's like something like that only, but it is generally what is percentile generally? For suppose this is a probability
It's
graph.
the
Okay.
percentage,
Can you
basically
repeat?
percentage. Percentage.
Yes, percentage. Yes, near about percentage, but percentile is different. Percentage. I'll read that then. Percentage and and percentile are different. Are different. First of all, what I'll do, write the definition of percentile. Percentage. Different. What is percentage? The what you may say. What I'll do. I'll Google it. The definition of percentage as well as percentile. To give an exact definition. Okay.
Mhm.
Hmm. What he's trying to say is that the amount of data that
Yeah.
the data point is holding,
Point is holding. Yeah.
correct, holding. I'm giving you some general definition. Just have read the definition here. I'm not
Oh,
giving you a textbook definition because it's difficult to understand. So I'm giving you some general definition. The amount of data that the data point is holding
got it.
in the entire data, in the entire data is known as percentage. I'll explain you the definition. Why it's simple is known as percentage. Means what? If suppose I have 60 marks from 100, 60 marks from 100. So what amount of data? What percentage of data this 60 is holding? So what I'll do? 60 divided by the total into 100. Yes or no? So this will be how we find the percentage. So
Mhm.
it is the number obtained upon total into 100. So it is 60%. Yes or no? Means 60 is holding
Yeah.
60% of data in 100. Yes or no? In the total data. Correct?
Yeah. Yes.
So this was the number, amount, rate, etc. of something expressed as if it is a part of the total, which is 100, a part or a share of a whole. Means, uh, for suppose this is a circle and this is the whole data. So my data, which I, for suppose I've scored this much of marks. So how much I've scored from the total? So it gives 50%. This is how the percentage is represented. Now we'll see for percentile. What is percentile? Yes. The percentile is a mathematical term that describes the number below which a proportion of data lies. Means what? I'll tell you. Percentile. What I'll do. The amount of data. The amount of data below that data point. Below that data point is what percentile tells us. Percentile tells us. I'll explain you this also with an example. For suppose there are entries here 1, 2, 4. These are all unique entries 2, 4, 10, 11, 12, 30. Okay. So I want to find the percentile of 4. I want to find the percentile of 4. So what I'll do, I'll see the formula. Hmm. Correct. So what we do? We have to calculate the percentile of 4. So what he has given the formula for percentile? Percentile is number of data points below the data point, below the data point for which percentile is to be calculated. For which percentile is to be calculated upon total number of data points, upon total number of data points. That's the thing. So we need to write the data in ascending order first. Then how many numbers are there before 4? How many numbers are there? 3, correct? And what is the total number of data points? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 by 9. So what is the percentile? So it's 1 by 3, which is about 0.33. Yes or no? Or 0.66? Have I made
Yes.
0.66? Sorry, 0.66. 0.66.
No, 0.33. No,
Oh,
it's
sorry, sorry. Oh,
two
I
thirds. This one's one
yes.
third.
Oh, yes, it's correct, correct. That's 0.33. So what does this mean? That 33% of the data, 33%. Now, what? See, this is percentile. This is percentile. But what does it tell? That 33% of the data lies 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 below 4. Lies below 4.
Within
Yes or
4.
no? Data point 4. Data point 4. DP4.
Mm-hmm.
Yes or no? Understood percentile? What is percentile there? With a simpler example. Am I able to deliver
Yes.
the main thing
Yes.
that I want to tell you? Okay, that's this. See here, the p percentile of a distribution is the value which p% of the observation less than or equal to it. Less than or equal to it. We can also include what we have calculated here. We have not included 4 in it. Yes or no? We are not included. We are just
Yeah.
taken that 3 numbers here. That how much data point is below 4. Okay. Am I audible?
Mm-hmm.
Okay.
Yeah, you are.
Okay. Okay. So what we'll do, we'll solve an example. Okay, come on. I'll take this on my. Just read the question. Till then, I'll just drink water. You also drink water. Water
Yeah.
has many of the benefits. It increases our flow of neurons also. So just a minute. I'm back. Thanks for waiting. Patience is
Mm-hmm.
appreciated. Okay. So refer to the dot plot of 25 scores of Mr. Tabau's first statistics test. Find the percentile for Jacob, who scored 18 on the test. Find the percentile for Jacob, who scored 18 on the test. Means I have to find the percentile of the 18th data point. So where is the 18th data point? Can you look at it?
Yep, it's the second one.
That's the second one. So what will be the percentile? Correct?
2 out of 25, which is
Oh, he's including it. What we have to do? We have to include this data point.
eight
Okay, I'll write this here in
eight
percentile.
percent.
Remember, so it will be 4/9 here. It will be 4/9. We can include it, but in this textbook, he's including it. So I'll write this uh, note here. Notes. We have to include the data points. Include the data points. The data points for which we are calculating calculating the calculating the percentile. That's it. Okay. So it's 2/25. So it is 0.08. So what does this mean? 8% of data, 8% of data lies below the score 18. Yes or no?
Yeah.
See, only two of the 25 scores in the class are less than or equal to. If we had taken 1/25, so it will be only less than. But we have taken 2/25, so it is less than or equal to Jacob 18 score in the test. Yes or no? So
Yeah.
what is the percentile? I have written this in percentage. So it is the 8th percentile. 8th percentile. See how is it written here? 8th percentile. Jacob scored at the 8th percentile on the test. Jacob scored at the 8th percentile in the test. This was the thing. Okay. So Maria's test score is the 48th percentile of the distribution. So she score is the 48th percentile of the distribution. Interpret this value in context. What score did Maria earn? That's simple. So I'm talking about Maria. Maria. So Maria is the 45th percentile. 45th percentile. So what formula do we have for percentile? So
48. It's 48. 48.
48. Oh, sorry, 48. So percentile is equals to number of data points below the data point, including the data point, okay, upon total number of data points. So see, we have this quantity as well as this quantity. Can we find this quantity? Yes or no? In any equation, in
Mhm.
any equation or formula, remember this is a what you may say quote. In any equation or formula, if there is one unknown, if there is one unknown means one missing value which we do not know, one unknown, we can easily find it by substituting the known ones. This is the basic of maths. By substituting the known ones. By substituting the known ones. So first, I'll write this again. P equals to number of data points below it upon total number of data points. So what is the percentile? 48. Correct? Equals to percentile I'm writing. So it would be 0.48. Yes or no, Zaid?
Yeah.
Yes. So we don't know small n, and big N is how many? There were 25 scores. So it's 25. Yes or no?
Yeah.
So here it's in division. When it will shift to the other side of the equals to, it will be in multiplication. So it will be 25 multiplied by 25. So it is 25 eights are, I think it's 25 eights are is 200, 0, 20 carry, 25 fours are 100, 120, 0, 12 carry, and 25 0 0 12. And 2 points below. So the the 12 data points. So now we need to calculate which is the 12 data point. So coming here onto this. Come on, count the 12 data point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I have went further. Oh, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the 12 data point. So where it is, see, 36, correct? 37, 38, 39, and 40. So it is 36 here. 36. So what is his score? What is her score?
I got
So the score
35.53.
35.53. Why? No, it's on 36.
Yeah, close
Correct? It's on
enough.
36.
You could around.
That's right. Yeah, okay. Therefore, the score of Maria is not for the score of Maria is 36. Score of Maria is 36. So
Mhm.
we'll look on 37. I missed a point in the calculation. We'll go back here. I'll erase this a minute. It's
Mm.
here. I guess then it will be 37. Yeah, it's correct. See, this is the point, not 12 points. So this is 36, and this dot plot is for 37. So 37. Yes, correct. You need to be very conscious in counting 37. Did you got that? All the reverse way, how to calculate the percentile, as well as how to calculate the score when the percentile is given. Was that interesting, Jay? I
Mhm.
enjoyed it.
Yeah, it was interesting.
Yes. Now is the cumulative relative frequency graph. It's very simple. I'll tell you. I'll explain you how it is. Okay. So what is we have seen frequency? Yes. In the previous chapter we had seen frequency. What it is? What was it? The count of a specific observation. The count of the specific observation in the data. In the data. And what was relative frequency? Once again, relative frequency, if you remember, it's very simple, nothing rocket science in it. The percentage, the percentage of the frequency is called as relative frequency. It's called as relative frequency. It's called as relative frequency, RF. RF. Or you can write the proportion of frequency, or you can say the ratio of frequency to the total count count is relative frequency. Okay, that's relative frequency. So now what is cumulative? What he has given here? He has given cumulative relative frequency. Okay, so first of all, we'll go through what is cumulative frequency. Cumulative frequency. Then I'll explain you what is cumulative relative frequency. How this occurs. This is not going, man. What is this happening? That's what is cumulative frequency. Cumulative, TIV, cumulative frequency. So suppose I have the observations. What I'll do, I'll take on this table only. It's very interesting, cumulative frequency, and it is required in graph. Can show you. Okay. Cumulative frequency. Huh? This is cumulative frequency. So what it is, what we have to do, it's very simple. What we have to do, write the first data point as it is. First data point as it is. Then we need to add this in the next one. What we need to do? We need to add these two, means 2 plus 7. So the cumulative frequency of this data point will be 9. Understood? Now for the next observation, we need to add the
Mhm.
preceding one and this. We need to add this. See, for the next data point. For the next data point. So it will be 9 plus 13. So it's around 22. So what will be the cumulative frequency of 50 to 55? It will be 22. For the next data point, we need to add 22 plus 12. So it will be 34. Correct? This for this.
Mm-hmm.
And next 34 plus 7. So it's 40, 41. Next 41 plus 3. So it's 44. And it's 44 plus 1. It's 45. Did you get that? How to do that?
Yeah.
And every time the last count of the what you may say frequency, the last count of the frequency will be equal to the total of the frequency. If you count the sum of the all the frequencies, it will be 45. You can verify this. The count summation of all the frequencies and the last cumulative frequency is always equal. It cannot be unequal. It is always equal, because what we are trying to do in the cumulative frequency, we are going to add step by step the cumulative frequency. Is it clear how to calculate the
Mm-hmm.
cumulative frequency? There is one more type of calculating the cumulative
Yeah.
frequency. We have calculated from upside. We can calculate it from downside also. I'll show you both the methods. So in the
Mm-hmm.
exam, if it is there, you will not be confused. You must be prepared for all the situations. Cumulative frequency. What we need to do, I started from upside. Now we have to write the first observation as it is here also. Then we need to add the this one and the upper one. So 1 plus 3, it will be 4. Then this 4, 4 plus 7, then it will be 11. Then this 11 plus 12, it will be 33. Correct? 33 or
Mm-hmm.
23?
Yeah.
23.
No,
23.
yeah, it is
Then
23.
23 plus 13, it will be 26, 36.
36.
36 plus 7, it will be 43. And 43 plus 2, it will be 45. Understood?
Mm-hmm.
There are both are called cumulative frequency, but there is a difference. This is called less than type. Less than type. If there is description given in your textbook, you'll see. But I have explained you. This is nothing hard and fast. It's very simple. More than type. Did you understand how to calculate it? Yeah.
Yep.
Yes. So what now? I'm expecting you to get an answer from you. What will be the relative cumulative frequency? Relative cumulative frequency. What do we do in relative? Where the word relative comes, what do we do generally? We take the our observation and divide it by the total. Yes or no?
Yeah.
Yeah, that's relative cumulative frequency. Nothing bigger than that. So we'll to divide 2 by 45. For this, if we want to calculate the cumulative frequency for the second observation, what we'll do? 9 by 45. If you find the cumulative frequency of the third observation, 22 by 45. If we need to find the fourth observation, 34 by 45. If we need to find for this, 41 by 45. This is how we go. And the cumulative frequency for the last observation, it is always 1. It is always 1. What does 1 mean?
Yep. The sum.
100%. Understood? You
Yeah.
got that?
Yeah. Yeah.
Yeah, that's good, man. See, see, see. You can match this, our graph, our calculation, and this. What I'll do, I'll do this. Okay. Where I'll paste. Okay. See, is this the same? Yes or no?
Mm-hmm.
Okay. See, and 2, 9, 22, 34, 41, 44, 45. See, this. And this, the relative. Why we are studying relative, cumulative, shift frequency? Why? This has an advantage. This has an advantage. This this gives us, gives us the direct value, value, the direct value of the percentile, of the percentile. And let's just see here, he has given a percentile. Yes or no? This gives us the direct. Means what? 2 by 45 means 4.4%.
Mhm.
Means the first
Yep.
data has a percentile 4.4. Yes or no? The second one gives 20.0, means 20th percentile the second data has. This cumulative frequency gives us the exact percentile of the data. Percentile. Percent.
Mhm.
Percentile. Understood? It
Yeah.
See, we were calculating percentile like was 1, 2, 3, 10, 12, 12. So if we are taking less than cumulative, I want to go in deep because of it. Less than type if we are taking. So this this will go. This much data lies below this. But if we are taking cumulative frequency greater than type, so this much, this will be the direction of the data. You don't have less than or greater than. If it is there, I'll go in that. You don't have, don't go in that. Don't go in depth. Just understand that the cumulative relative frequency gives us the knowledge about percentile and shows us how much data points are below that. How much data point is below that. Okay. Now we move
Mhm.
on. Move on to the graph, cumulative relative frequency graph. It's very simple. What we need to do, see. For the first, it was 4.4. Yes or no? I'll take it here. Wait,
Mhm.
I'll take this here. Every time the for the cumulative frequency, likewise for the relative frequency that we had studied earlier, it had the values always in percentage. Yes or no? And we had drawn the bars there according to the percentage in the relative frequency that we had studied in the previous chapter. Now what we have to do: 0%, 20%, 40%, 60%, 80%, and 100%. For 40 to 45, what was our point? Near about 4.4%. Yes or no? So this is the data point.
Yeah.
For 45 to 50, how much was our data? Around 20. So see, it's the points is around 20. Correct? For 50 to 55, I'll look in here in this table because we have not calculated it. 48, around 48. So it will be at 48. So see, this 55th point is around 48. See, this is 50. So it's around 48. Okay. Then it's 75. Next is 75. So the upper interval is marking the point. So this is the upper interval. This is marking the point. This is the upper interval of the data. This is marking the point. How much it is showing? Near about 90. So we'll see it is 90. See this 90, near about 90. Yes or no? Then the next one is 97. This one is around
Mhm.
97. And the last one always show, the last one here always show 100, always show 100. So what we need to do, once we have plotted the points, and we had reached to 100, once we had reached to 100, 100, so we need to join these points. How we need to join? Our starting interval point, suppose it's 40, so we need to join line by line, line by line, line by line,
Mhm.
line by line. So this is the cumulative, relative, relative, cumulative frequency graph. Did you get that, Zaid?
Yeah, I got that. I got.
Okay, so now you need to solve this example and send me on my WhatsApp this example. It is solved, but you need to solve it in your book. Will you do that?
Yeah, I'll do that.
Okay, thank you, thank you, thank you. Chalo, assalamu alaikum. It's the call of the day. Okay, now we'll
All right.
join in the evening. Today you'll join in
Okay.
the evening, yes, right? Today you don't have any school.
Yes.
Okay, thank you very much.
Yeah, I
Assalamu
don't have any
alaikum.
school. Yeah.